Here bringing you the IM3 Honors 4-2 Extra Practice number 4 solutions on completing the square. There's a puzzle that goes with this. Let's go ahead and take a look at that. So here's a look at the puzzle that we're going to be wrestling with on this one. We're trying to solve the riddle of what is the title of this picture. It's just a triangle and a line, so very abstract. I can't wait to see what the title is on this thing. To get there, we have to solve these problems by completing the square. And once we solve one of these, we have to look for the answer down in this box below and put the letter next to the answer above the blank that goes with the problem. So here's an example. If we solve problem 1 and let's say we find that F is the answer. I don't know if it is or not, but if it were, then above spots that had a 1 next to them, we would write an F to fill this in. And we just keep going until we've filled in everything. All right, so here's the first problem we're trying to solve with completing the square. We have an x squared plus 6x equals 16. Since I've got a 1 next to the x squared and no constant on the left side, I can actually go ahead and complete the square right off the bat. So half of 6 is going to be 3. I'm going to square 3 and add that to both sides here. That allows me to factor the left side into x plus 3 squared. That's using our shortcut here, our a squared plus 2ab plus b squared equals a plus b squared shortcut. And we're going to keep using this for this entire puzzle. Now on the right side, I'll clean this up. This is 16 plus 9, so that's 25. Now I can square root both sides. When I do that on the left side, that gets rid of the squared parentheses, so I have just x plus 3. On the right side, remember you have to have a plus or minus thrown in when you square root to solve an equation. So this is plus or minus square root of 25, or 5. Subtracting 3 to get x by itself, now I have negative 3 plus or minus 5. And then I have to actually simplify this a little bit. Negative 3 plus 5 is 2. Negative 3 minus 5 is negative 8. Looking for that in my answer set, I see that that's going to be letter R over here on the left. So wherever I see a 1 down below, I'm going to put an R above that spot. So there's an R right there. And I see another one actually over there, so we got to use that one twice. For the next problem, again, I noticed that I have a squared coefficient of 1 and no constant on the left, so let me complete the square. So half of 10, the middle coefficient here is 5. Squaring that and adding it to both sides, so plus 5 squared plus 5 squared. That allows me on the left side to factor this now into a plus 5 quantity squared. And on the right side, I've got negative 21 plus 25, which is 4. Square rooting both sides, I have a plus 5 equals plus or minus 2, square root of 4. Subtracting the 5 over there, let me go ahead and simplify a. It should say a equals. Same difference, though. So we got negative 5 plus 2, which is negative 3, and negative 5 minus 2, giving us negative 7. So negative 3, negative 7, that's n right here. So wherever I see the number 2, because it was problem 2, I'm going to put an n, so right there. And also, I do see another one over there. Solve this by completing the square. I can go ahead and take half of negative 8, which is negative 4. Square that and add that to both sides. So that gives me an x minus 4 quantity squared on the left, 33 plus 16 on the right. That's 49 over there. Square rooting both sides, I've got x minus 4 and plus or minus 7. Adding 4 over there, 4 plus 7 gives me 11. 4 minus 7 is negative 3. 11 and negative 3, that's a y, so I'm putting that in spot 3. For this one, we've got squared coefficient of 1, no constant on the left. Let me complete the square. Half of negative 4 is negative 2. Let's square negative 2 and add that to both sides. So we've got n minus 2 quantity squared on the left and 11 plus 4 on the right, which gives us 15 over there. Square rooting both sides, we have n minus 2 equals plus or minus square root of 15, which I can't really simplify. There's no perfect squares. It's not a perfect square itself. So that's as good as that gets. So I just have to add 2 to the other side. So 2 plus or minus radical 15 would be our final answer, and that's C right here. So we've got a C going above this 4, and I don't think there's any other 4s out here, so we move on to the next. For this problem, I'm all set up to complete the square since I don't have any constant over here. So half of 20, that's going to be 10. Let me square 10 and add that to both sides. On the left side, that leaves us with b plus 10 quantity squared. On the right side, we've got negative 80 plus 100, which is 20. Now I'm going to square root both sides. That leaves me with b plus 10 on the left side. And on the right side, the square root of 20, I can actually split that up into 4 times 5 under a radical. So square root of 4 is going to be 2. So, and let me also subtract 10 from both sides. So I'm going to have negative 10 plus or minus 2 radical 5. Can't really go any further with simplifying, so let me find that answer. That's right over here, a. So 5 is going to be a then. So there's an a right there. And is there another 5? Yep, right there. There's another a. For this problem, I've got squared coefficient of 1, no constant on the left, so let's complete the square. Half of negative 12 is negative 6, so we're squaring negative 6 and adding that to both sides. On the left side, that factors into x minus 6 quantity squared. For the right side, that's going to be 39 plus 36. And let's see here, that's going to be 45 plus another 30 is going to give me 75. Let's go ahead and square root both sides. We have x minus 6 on the left, and we have the square root of 75 on the right side. Now, I can split that up. 75 is not a perfect square, but we can break it up into 25 times 3, and 25 is a perfect square, so plus or minus that. And then just getting x by itself and simplifying all at once here, we're going to have x equals positive 6, since I'm adding that over to the right side, plus or minus 5 radical 3. So that's w right there. So we put that next to the 6 right there, and that's the only one. Before I can complete the square to solve this problem, I have to clear this 1 out, leaving my left side without a constant. So I'll add that over and get positive 1 on the right side. Now I'm going to take half of negative 6, which is negative 3, square that and add that to both sides. On the left side now I can factor that as m minus 3 quantity squared. On the right side this is 1 plus 9, which is 10. And then square rooting both sides, we've got m minus 3 on the left and plus or minus square root of 10. 10 is as simple as it gets. There's no perfect squares I can break this up into. So I'm just going to add 3 over to the right side. So then 3 plus or minus radical 10 is my answer. That's going to be u, which goes on spot 7. So there's a 7 right there, and I don't see any other 7s. Complete the square on this one. Let me add 20 over to the other side to clear out that constant. And now I'm going to take half of negative 8, which is negative 4, square that and add that to both sides. For the left side, I have 10 minus 4 quantity squared if I factor that. For the right side, this is 20 plus 16, which is 36. Square rooting both sides, I've got t minus 4 on the left and plus or minus square root of 36, which is 6 on the right side. Now let me add the 4 over to the other side. 4 plus 6 would be 10. 4 minus 6 is going to give my other answer of negative 2. So 10 and negative 2, that's an E right there. That's going on spot 8. So there's an 8 right there, and another 8 over here, and I think that's it for 8s. Complete the square here. Let me go ahead and subtract that 18 to clear out that constant. Now I can take half of 12, square that, and add it to both sides. So I'm adding 6 squared to each side of the equation to complete the square. For the left side, I've got an x and a plus 6 quantity squared when I factor that. Over on the right, I have negative 18 plus 36, which is positive 18. Square rooting both sides, I have x plus 6 on the left, and then the square root of 18 plus or minus that on the right. Now 18, I can actually split that up into 9 and 2, because 9 is a perfect square. So getting x by itself, I'm going to subtract 6, so I have x equals negative 6, and then I have this other stuff that was already there. So plus or minus 3 radical 2. Negative 6 plus or minus 3 radical 2, that's down at the very bottom here, that's an m. So 9 is m, and there's only one 9 at the very end right here. Here we go, number 10. So to complete the square here, I want to add that 80 over to the right side, just so I can clear out that constant and be freed up to add whatever I want on both sides. So now I take half of my middle coefficient, half of this 2 here is 1. So I'm doing 1 squared and adding that to both sides. So on the left side, I've got y plus 1 quantity squared. On the right side, 80 plus 1 squared, that's just 80 plus 1, which is just 81. Now I can square root both sides. That's y plus 1 on the left, and plus or minus the square root of 81, which is 9 on the right side. Getting y by itself, let's subtract 1 over there. Negative 1 plus 9 is 8. Negative 1 minus 9 is negative 10. So 8 and negative 10, that's an F right there. So that's what I'm going to put above spot 10. And I only see one 10 that's right here. And then everything else is 11 through 14. For this next one, to complete the square, I'm going to add 7 over to the right side. There's already a 3 over there, so that gives me a 10. And then half of this 10, this middle 10 here, this negative 10, that's negative 5. I'll square that and add negative 5 squared to both sides. So for the left, factoring that, I've got x minus 5 quantity squared. On the right, we have 10 plus 25, which is 35. Square rooting both sides, I've got x minus 5 on the left, and the square root of 35 plus or minus that on the right. 35 doesn't have any perfect square factors, so that's as simplified as that's going to get. So just add 5 over there, and we have x equals 5 plus or minus radical 35. I see that at the very beginning of my list here, that's a B, so 11 is going to be B. I've got an 11 right here, and scanning for another 11, I don't see any more, so we're moving on to 12. To get started on this one, I'm going to subtract 60 from both sides, so I have no constant on the left. 5 minus 60 gives me negative 55. So now let me take half of 16, which is 8, square that and add it to both sides. So 8 squared there. That gives me a k plus 8 quantity squared on the left. And then we have negative 55 plus 64 on the right side. That gives me a 9 over on the right. Square rooting both sides, we have k plus 8 equals plus or minus square root of 9 plus or minus 3. Subtracting 8, I have negative 8 plus 3, which is negative 5, and negative 8 minus 3, which is negative 11. And I see both of those answers over here with option O. So that's what 12 is an O. So we get an O here, and there's another 12 right there, so there's another O. Any more 12s? Any more 12s? Here's another 12, and a fourth 12. So we got a lot of mileage out of the O there. To do this next one, I'm going to subtract 30 from both sides so I can complete the square. Negative 30 minus, or I should say subtract 70. So negative 30 minus 70 is negative 100 over there. Half of negative 24 is negative 12, so I'm adding negative 12 squared to both sides. That gives me x minus 12 squared on the left, and then negative 100 plus, that's 144 over on the right. So that's going to be positive 44 for that right side. Square rooting both sides, I've got x minus 12 on the left, and then plus or minus square root of 44 on the right. Now 44, I can break that up into 4 times 11, because 4 is a perfect square. So let me get x by itself now. Add 12 over to the right side, and then I've got plus or minus 2 radical 11. So 12 plus or minus 2 radical 11, that's a t. So 13 is a t. There's a t right there. And another one right after it, and another 13 down here, and back here as well. Don't want to forget about that one. And then finally a fifth t over here with that one. So t is the clear winner on most repeated. Now I'm down to my last problem. See what I'm filling in for all these 14s here. So to complete the square for this, let me add 75 over to that 100 to get 175. And now I'm taking half of 30. That seems huge. Half of 30, that's 15. Squaring that and adding it to both sides. On the left, I've got y plus 15 quantity squared. This is getting kind of scary. On the right side, 175 plus, I think that's 225. Now this is actually going to be kind of nice because that stuff on the right adds up to 400, which is a perfect square. So now when I take my square root of both sides, I've got y plus 15 on the left and plus or minus 20 on the right side. Square root of 400 is 20. Subtracting 15 from both sides, y equals negative 15 plus 20, which is 5, and negative 15 minus 20, negative 35. So 5 and negative 35, that's going to be an S. So 14 is an S right there, and another S right there, and finally this last one here. Awesome. At this point, we are ready to solve the puzzle, which is what is the title of this picture? So looking through my letters, I see Boy Scout, so Boy Scout, and then T-E-N-T, that's a tent, that makes sense. Boy Scouts have tents. And then I see A-F-T-E-R, so after, I think that's just the word and then snowstorm. So this is a Boy Scout tent after a snowstorm. It's buried under there. Very funny. Till next time, Mr. Sutton signing off.